Okay, good morning class. We're on to mathematics and this is algebra for grade 8. And we've been trying to look at linear equations and the concept of trying to balance out equations. We said previously that the concept of balancing equations takes into consideration trying to make what you have on the left hand side to be directly equivalent to that you have on your left hand side equal to right hand side. This morning we'll be looking at something rather interesting. We call it balancing involving fractions. Balancing involving fractions. Balancing involving fractions. Now, anytime you mention fractions, one key word should come to your mind. LCM or LCD. Essentially, they are the same thing. Lowest common multiple, but when you are treating fractions, you now call it lowest common denominator. So the technique we're going to be using in handling equations, linear equations, having to do with fraction will be the concept of what? LCM or LCD. Okay, we'll be looking at exercise 13D of our textbook. Our textbook reference will be New General Mathematics for JS2, and then we'll be looking at page 103. This is Mamu Jarvis, and we are dedicated to giving you a lovely mathematics experience. So we'll go straight to the coursework for today by trying to use our knowledge of balancing method to handle equations having fractions. If you look at the board, we have x over 3 equal to 5. Here, your attention should be on the fraction part, because in balancing equations, one of the things we've said first is that we do not have anything called negative. So the reason why you try to balance is to ensure that you do not see a negative as the coefficient of the unknown. What is the unknown? The unknown is x in this setup. Letters are used to represent what? Unknowns. And unknowns are values or letters whose values can vary depending on the problem. Now, if you look at this question closely, you have a fraction on the left hand side. The basic rule here, to clear a fraction, you introduce what? A whole number. So if I have x over 3 equal to 5, to clear that 3, all I need to do is to multiply the left hand side and the right hand side by 3. And when I do that, I'm going to have that this will cancel this exactly out, and I'm going to have x equal to what? 15, and that takes care of that problem. X equal to 15. Notice that we have not talked about LCM, but codedly we are actually using LCM because a student can say this over 1, and if I compare 3 and 1, the LCM of 3 and 1, or the LCD, which is called in this arrangement, will be what? 3. So the rule says that multiply the left hand side and the right hand side by the LCD. In this case, the LCD is 3, and that would help clear up the 3 here and makes the coefficient of x to become 1. So x becomes equal to 15, and that clears out that problem. So here we are presented with another situation where we have x over 5 equal to what? 1 over 2. Now, as a principle, I would have just said multiply through by LCD and that takes care of it. But there is a little adjustment to the rule here. Your focus is always on the left hand side. What do you have as the denominator of the left hand side? It is 5. So it is that 5 you're going to multiply both sides by. Maths is such an interesting subject that we do not tie ourselves to particular rules. What you do is a function of what can help you. So, if you look at this problem now, what is the first thing I need to do? I want to make the coefficient of x 1. What is the LCD of this? It is what? 10, because it is what? 5 and 2. But will that help me? That will give me extra work. So I will just simply say x over 5, multiply this by 5, equal to 1 over 2, multiply this by 5. I cancel out, and I'm going to have that x will be equal to what? This 5 seconds 5 over 1. I remember that from your elementary arithmetic, when you are multiplying, numerator will multiply numerator, and what? Denominator will multiply what? Denominator. So if you do that, x will now be equal to what? 5 over 2. And that takes care of that problem. Alright, we go to question 6. And in this question we have one whole number, 1 over 2, minus 3x over 4 equal to what? 0. Now, if you look at this very well, we said that for any equation, our objective is to keep the unknown on the left hand side and keep the number on the right hand side, assuming this is what we are supposed to take care of. So, if you look at this, the unknown is a negative and is on the left hand side. So the first thing you need to do, because we said that the unknown must be a positive. So what should you now do? The first thing you need to do is to add 3x over 4 to both sides. That's the first thing you need to do, because you want to make this a positive. With that, you're going to have 1 over 2 equal to what? 3x over 4. Remember we said that a number minus itself is 0. Negative a certain number plus itself is what? 0 also. So we have been able to handle this part. Now the next thing you want to do is to keep this rewrite, keep this on the left hand side and keep this on the right hand side. But before you do that, I would advise you to change this to what? Improper fraction. The general practice in maths is to multiply and divide in the improper mode. We multiply and we divide numbers in the improper mode. So the next thing you do is to convert this to improper fraction, which will be 3 over 2. This times this plus this over this equal to 3x over 4. And this will give us what? 3x over 4 equal to 3 over 2. Okay, this is where I expect my students to pay very close attention. With my years of solving problems in mathematics, I've come to learn that what makes you an outstanding mathematician is your attention to details. Now, some people will just say, find the LCM and move away. No. There's a topic you have been taught, and it's called factors. Factors is a weapon or among your arsenal. You need to use it. You need to use it. The tools you have, use them. If you watch carefully, I can cancel 3 and 3 here. Factors. If you watch carefully again, factors, this is even, I can cancel this, and I can cancel this. So what do you have? You're going to have x over 2 equal to what? 1. It is at this point you cannot multiply by 2. So this will be x over 2 times 2 equal to 1 times 2. And what does that give you? X will now be equal to what? 2. And that solves the question. So you see that if you're using your normal conventional approach where you just rush, okay, I always like you to think. As you solve problems, you build your stamina in maths by thinking. Solve the problem, you think, why am I doing this? Okay, my teacher has said this is what I should do, but looking at it, this is what I think I should do. Do it. You've not broken any rule if you go like this. In fact, you're a smarter student if you have gone this way. Okay, so let's look at that and then we'll go to another question. In question 7, this is what you have. What's your denominator?
3.
So you then say x minus 2 divided by 3 times 3. Because you want to clear the denominator. Equal to 4 times 3. So you cancel out. And then you're going to have that what? X minus 2 is equal to 12. So we don't need this negative 2 here. What do you do to negative to clear it? You add. So you add 2 here. You add 2 here. And that means that x will be equal to what? 14. And you have solved that. So you see that it's faster. Once you get the process right, it becomes very fast and easy for you to handle. Okay, we have yet another question on the board. We have question 15 of that exercise. 5x minus 8 over 2 equal to 2x. Now you will notice that in taking these exercises, I've had to job some because after question 7, the exercise, the questions there will follow the same pattern. That the same pattern is repetitive in nature. So just take out time in your personal time where you're solving. Solve one to the next to the next. The pattern will be the same. Now here we have a different pattern. Would I call it different? Here you have what? X, an unknown on this side, and you have an unknown on this side. So what you do first is to take care of the denominator. That's the thing with fraction. You must handle the denominator. Here you have to be careful. Whenever you have an unknown here, and you have unknowns expressed here, you need to keep the LCM concept alive. Okay, so from here you're going to have 5x minus 8 over 2 times 2 equal to 2x times 2. So this will go with this and we'll be left with 5x minus 8 equal to 4x. Now remember that I want the unknown on the left hand side and I want the known, which are the numbers, on the right hand side. But if you followed our classes to this moment, you remember that we said that you need to compare your unknowns. 5 is bigger than 4. So it means that in moving, 5 will remain where it is, and I will have to move 4 to where 5 is. So it is based on this, I will now know that I need to remove 4x from both sides. When I do that, I'm going to have that what? X minus 8 will be equal to what? 0. What's the next thing I'll do? I don't need a number on the left hand side. So what do? I remove. And because it's negative, the only way to remove a negative is to add. This becomes x minus 8 plus 8 equal to 0 plus 8. And invariably x will now be equal to 8. You see that it's very straightforward. It's very straightforward, but it's a little demanding. It's good. It's good exercise for your brain, especially your mental aspect of your brain. It's very, very good. And as you do this, you get to appreciate why, when you're talking about, okay, you move this to the other side, you know why you're moving it. That's one of the objectives of balancing method. It tells you why, it helps you understand why you make certain decisions. So that will solve question 15, and then we'll take a question that would now test our ability to use LCM in its real context. Alright, let's look at the question on the board. 6m minus 3 over 7 is equal to 2m plus 1 over 7. How do you go about solving this problem? See, when we teach, we give you principles, but you must understand that smartness is a measure of when to use a principle. Smartness is a measure of what? When to use a principle. If you observe and if you look at the denominators, they are both what? 7. So you can cancel out straight. And you simply will have 6m minus 3 equal to 2m plus 1. So sometimes when you see students solve things in seconds, it's about your ability to quickly see. So in solving this problem, the first thing I will need you to look at is, are the denominators the same? If yes, cancel out. If they are not the same, is there a common factor? If there is no common factor, use LCM. The reason you're using LCM here is because you have an unknown here and you have an unknown here. So let's proceed in solving this. Now, 6m is greater than what? 2m. So we have 6m minus 2m minus 3 equal to 2m minus 2m plus 1. With that said, we're going to have what? 4m minus 3 equal to what? 1. I do not need negative 3 here, so what do? I will add 3 to both sides. So this will be 4m minus 3 plus 3 equal to 1 plus 3. I have 4m equal to what? 4. At this point, what's common to both sides? 4. So I do divide both sides by 4, and I'm going to have that m is equal to what? 1. And that clears out question 27. So what has happened? In this question, you need to know what to do. You need to clear the denominators because they are the same. So that's what we're expected to do here. Alright. Okay, in considering this question, we look at the denominator. If you look at the denominator, this is 4, this is 6. So 2 can divide this, and 2 can divide this. Is that clear? So the next thing you want to do is to what? Clear the denominators. Now, it is in this context you use your LCD. What's the LCD of 2 and 3? It will be what? 6. The LCD of 2 and 3 will be what? 6. It's like looking for the LCM. Now, you will multiply this by 6 and multiply this by 6. So you're going to have something like this. 3 into 2a plus 1 times 6 all over 2 equal to 5 into what? A plus 5 times 6 divided by 3. I seen that. So at this point, what do? You cancel out. 1, 3, 1, 2. Please, when you're having problems like this, don't be in a hurry. Don't be in a hurry. Rush. When you rush, you could make mistakes, especially when you're trying to understand the concept. Whenever you're trying to understand the concept, never be in a hurry. Take it one idea at a time. So if that is understood, the next thing I'll do, I'll multiply this 3 with this 3. I'm going to have what? 9 into 2a plus 1. Notice I have not opened brackets yet. Don't do that. Take it one step at a time. I'll multiply what? 5 with 2. And I'm going to have what? 10 into what? A plus 5. I see that. The next thing you do is to open up the brackets. Now, this 9 will affect this and this. This 10 will affect what? This A and this 5. So this will give me what? 18A plus 9 equal to 10A plus 50. 10 times 5 is what? 50. The next thing you do is to say 18A. Now, you compare 18A and 10A. You discover that you do not need 10A here based on our rule. We keep the unknown on the left hand side and we keep the known, which are the numbers, on the right hand side. So this will be 18A minus 10A. Are we seeing that? Plus 9 equal to 10A minus 10. We are sitting above that now. 10A plus what? 50. So what does that give you? This will give you what? 8A plus 9 equal to what? 50. At this point, what don't I need on the left hand side? I don't need 9 because this is not where it should be. So pack your load and go. Plus 9 minus 9 equal to 50 minus 9. So which means that what? 8A will now be equal to what? 41. I divide both sides with 8 and I'll have that A is equal to 41 over 8. You don't need to bother converting to mixed numbers. It's not necessary. You just keep it this way and that will suffice as your answer. Okay, we have the next question, which is question 29. And here we have 3 terms. 2 of the terms on the left hand side and 1 term on the right hand side. In solving this, you need to know your LCM or LCD. There is 3, there's 4, and there's what? 2. The LCD of this will be 12. Just by way of helping you remember what has happened. So the LCD becomes what? 2 times 2 times 4. So that's 12. So you multiply each of the terms by what? 12. So this will be 12 multiplying 2a minus 1 over 3 minus 12 multiplying a plus 4, a plus 5 over 4 plus 12 rather equal to 12 over what? 2. This and this will give you 4 into 2a minus 1 minus 3 into a plus 5. Notice that I'm now using brackets. I'm using brackets because I have a negative here, and this will be equal to what? 6. The next step is to open this bracket. I'm going to have what? 8a minus 4. This negative will multiply the bracket, and you have negative 3a, negative 15 equal to what? 6. Treat these brackets first. 8a minus 3a will give you what? 5a. And negative 4 minus 15 will give you what? Negative what? 19 equal to what? 6. The next thing you do, we don't need 19 here, so you add 19 to both sides. So this will be 5a minus 19 plus 19 equal to 6 plus 19. So 5a will be equal to 25, and then I'll divide both sides by 5, and a will be equal to 5. So the answer to that question will be a equal to 5. Alright, we'll pause here and call it a day with our Mawu experience, and we hope to continue in our next class with balancing involving word problem.
Yes.
And in that class, we'll try to look at how you handle word problems. And as my practice is for that, once I've generated the equation for you, I expect you to finish the problem. So you need to go back to my previous videos to see what relevant steps you need to follow to finish out the question. Thank you for the time you have spent with us. And this is Mambo Ijabi signing out for today.